Hello, everybody. Today we're going to be working on session number 9, and this session is actually deals with categorical data. To work with this session, we're going to start easily. We're going to look at the Pearson chi-square. We're going to spend a lot of time here. So I have a data set that is named CVD coffee data, and I have been using this data set in many occasions to explain the concept of confounding. But for now, just don't worry about the idea now. We'll come back to that in a minute. Basically, let's first investigate how the data looks like. I'm going to start by removing the value labels. I have one variable, two, three, and four. The first variable is smoking. The second variable is CVD. The third variable is coffee. And the last variable is frequency. Obviously, the first three variables are coded 1 and 0 just to indicate the presence and the absence of the variable. So 1 if they're smoking, 0 not smoking. For CBD, the same thing, and for coffee, the same thing, then whether they use coffee or not. The last variable is a frequency variable, and this is one of the instances where you're not going to get a record per individual. So we're not getting every individual represented by a single record. Rather, what we're getting is every profile is represented through one record. What I mean by profile, if you look closely, you have 111. So smoking present, CVD present, and coffee present. I have the frequency is 5, and I have 5 individuals that meet that profile. And if you think about it, smoking has two possibilities, yes and no, CBD 2, coffee 2. So a 2 times 2 times 2, that is 4. And sure enough, you will find that we have 2 times 2 times 2 is 8, I'm sorry. And we have 8 different profiles represented by the 8 different rows. And what you have at the end is the frequency, meaning the number of individuals that belong to each of the profile. So for example, the 270, these are those that are smokers but do not have CBD and do not have coffee. Now, to be able to analyze the data, the first thing that we ought to do is go to data and go to weight cases and request the data to be weighted by frequency. I'm not going to do that right away. I just want to show you what happens if you do not do this. So if let's suppose I'm interested in knowing if there is a relationship between smoking and coffee. The way to do this is you go to analyze, you go to descriptive statistics, and you go to cross tab. So let me hit the reset button. What you're doing is you're creating a contingency table that has rows and columns, and you're going to decide what to put in the rows and what to put in the columns. Personally, I prefer to put the groups in the columns, yani, which are the groups I'm going to compare. So for me, I want to compare the smokers to the non-smokers. So I will put them in the columns. And my outcome is presence or absence of CVD. So I'm going to put them in the rows. Okay. And for now, I'm not going to hit anything else. I'm just going to go with OK button. All right. So let me reset the whole thing. I think it actually weighted things, though it should not have weighted. Let me go back. Data, weight cases, do not wait, reset, okay. Right, so let me repeat. Cross tabs. So I have CBD smoking. Um, okay, here we go. This is exactly what you will get. You will get a table like this one. Of course, the first table is just the summary table. The second table is the table of your analysis, which shows smoking. So no and yes as the smokers, the two columns that I would like to compare, and the CVD, whether there's no CVD or presence of CVD. But if you look closely, you're getting 222 in every cells, and the total is 8. The reason for that is when we're analyzing the data as if every individual record is an individual person, which is not a case as I told you previously. Yani so far, SPSS is just looking at this data right there, and SPSS is considering that there is only 8 records, which is not the case. So SPSS is seeing two of these, two of these, two of these, and two of these. Okay, so the right thing to do is to go and um, data, as I mentioned previously, go to weight cases, and on the weight cases, you're going to pick frequency and ask SPSS to weight using the freq variable. Okay, so what that does is that now SPSS understands that the values that are going to appear inside the cells are not the counting that SPSS is doing, rather the frequency provided by the data set. So let's repeat: analyze, descriptive statistics, cross tab, everything is the same. So we're going to click OK. All right, so now we're getting a better and better table. The summary table is always what you get. And here's again the smoking, no smoking, and yes smoking, and the CVD, no and yes. And you can see that I have 450 non-smokers, 350 smokers, for a total of 800 individuals in my sample. And out of the 450 smokers, 270 have CVD, and out of the 315 smokers, 35 have CVD. Obviously, you would like to see percentages as well, and you would also like to see if there is statistical significance. So we're going to repeat, but this time we're going to add more details. So cross tab, we're going to go to click on cells. Now under cells, we have the count observed that is already clicked. We're not going to pick anything. We're just going to go to percentages, and we're going to request the percentages. Now you have 3 different ways or different types of percentages: the row percentages, the column percentages, and the total percentages. Now the difference between them is that the row percentages add up to 100 by rows. Yani it will be the 180 divided by the 495, the 315 divided by the 495, and so on and so forth. You have the column totals, which will add up to 100 by column. So it will divide the 180 by 450 and the 270 by 450. Same thing in this column. And the total percentage, which will divide every cell by the overall total. Usually, if you're putting, like, if you did as I did, your groups are in the columns. Usually you want to compare percentages inside the columns. So what you need to do is click on the column percent, click continue. That will give you the percentages, but it will not give you the p-value. Now to get the p-value, you have to go to statistics, and you're going to pick the chi-square. This is the appropriate test to be used when you have categorical data, comparing groups by categorical outcome. So we're going to click on continue, and we're just going to go with OK. Okay, now notice that the table now has more information. As I told you previously, you're going to get the percentages that add up to 100. So 40% plus 60%, they add up to 100%, and 90% plus 10% add up to 100%. And you also have the percentages for the total. Okay. Also, you're going to get the chi-square table, which has a lot of chi-squares. What we usually want is the Pearson chi-square, the first one that appears in the first row. And a requirement for that is that the expected cells should not exceed 20%. So you look at the A right here, and it tells 0 cells, yani 0% have expected count less than 5. Okay, that percentage should be below 20 to 25%. As long as that percentage is below the 20 or 25%, you're fine. You can use the Pearson chi-square. If that percent start hitting the 30, 40, 50%, then you have to use the Fisher exact test. Okay? Now the Fisher exact test does not produce a value or a degree of freedom, it only produces a p-values. Now in our situation, the percentage of expected cells less than 5 is 0%, so we're fine. We're going to use the Pearson chi-square. The value of the Pearson chi-square is 208. There's only 1 degrees of freedom, and again, the p-value is what is represented using the significance, okay? And it comes out to be 0.000. meaning the p-value is very small. And as I mentioned previously, if you request this cell to have more um, uh, decimal points, you will be able to see that actually it's not zero. So I'm adding more decimal points. Okay, even more decimal points. Maybe it's too small to show. Wow, this p-value is really, really small. Let's see if I can add. Whoa. Okay. So it has a lot of zeros. It's almost equal to zero. But if you go, if you I think it's showing when I'm. I don't know if you had a chance to see it. When I moved my cursor, it kind of like show me how many trailing zero there will be before you will be able to see some value. Anyway, this is not important. The important thing is when you see a zeros as a p-value, just remember it's not really a zero. It's a very, very small number. So you report it as less than 0.001, for example. Now, the other thing I want to point out is that you need to analyze the results. So you need to look at what the results are saying. So if you look at the non-smokers, those that have CVD are 270, meaning 60% of the non-smokers have CVD, compared to if you look at the smokers, 35 out of 350, that's 10%. So 60% of the non-smokers have CVD compared to 10%. Obviously, this is something is wrong in this data set. And I think when I created this data set, I mistakenly put the zeros instead of the ones. Now, to correct for that, what you need to do is simply just go back to the data, go under variable view, and for CVD, just change the coding. So the no becomes the yes, and the one becomes the no. And I think that should take care of it. Let's rerun the study, cross tab, rerun, and yeah. No, I think I made a mistake. I'm sorry. I think it's the smokers that needs to be switched. It's the smokers that needs to be switched. I apologize. Let's go back. Let's fix this. So we go back to no change, and yes, I'm fixing the CVD. The CVD is fine. It's the coffee. It's the smoking that needs to be fixed. There are two ways to fix this. Either you change the value label or you go back to your data. And for smoking, we're going to flip the zeros and the ones. Okay. Okay. So let's try this. We're going to put four zeros and four ones. So try to change it. Zero, 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 and then one, 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 one. Okay, I hope that fixed the problem. Let's repeat the analysis, cross tab, click OK. And so now it's 60% of the smokers that have CVD and 10% of the non-smokers that have CVD. This makes perfect sense. Okay. Um, Another thing that you can do when you're doing a table like this is create something called the odds ratio that you probably have seen in pharmacoepidemiology. So if you want to calculate an odds ratio, you'd have to request it. So let's request an odds ratio. Analyze. We're going just to go back, cross tab. And for statistics, you are going to request a risk. Click continue and click OK. So again, you're getting your table with your percentages, your chi-squares, and now you have another table that is titled risk estimate. The first row is an odds ratio row, and the other two rows are a relative risk. In this instance, we're not calculating the relative risk, so I'm just going to ignore the relative risk. I'm just going to focus on the odds ratio. and the odds ratio comes out to be equal to 13.5 with a confidence interval of 9 all the way up to 20. For those of you that remember what the odds ratio stands for, this is the odds of the disease among smoker over the odds of the disease among the non-smokers. Yani smokers have 13.5 higher odds of having CVD than non-smokers, and the confidence interval for that odds ratio goes from 9 to 20. It does not cross 1 because 1 indicates a no difference in the odds since it's a ratio. Every time it's a ratio, 1 is indicative of no difference. The confidence interval does not include 1, and therefore it's statistically significant. So this way we have covered how to create a cross tabulation table with the percentages and the actual value of the chi-square with the p-value, and how to get also an odds ratio and interpret the odds ratio. If you want to use this table in your presentation, usually we like to represent the table with the n and next to it the percentage, not below it. What you can do is double click on the table so that it becomes active, right click and go down to pivoting trays, and then take the statistics, put it under smoking, and then close. And now what you have is for the non-smokers you have the count and the percentage, and for the smokers you have the count and the percentage next to each other, which makes it much easier to read. Or if you want to take it and copy this table to a Word document, it becomes much easier to work with. What I'm going to do now is I'm going to repeat the analysis, but I'm going to put more percentages just to show you what kind of percentages you can get. So I'm going to repeat crosstab. I will remove the statistics this time. I don't need to see the statistics every time I run this. Just go under cells and remove the column, put row, and can click continue. Okay. And now what you're getting is the percentages in the rows. Yani the 63.6 and the 36.4, they add up to 100. So the 63.6 represents the 315 over. And this is the percentage among those that do not have CVD. So among this group right there, the non-smokers are 36.6 and the smokers are 36.4. I may have said that the wrong way. Let me repeat. Among non-CVD patients, yani those that are healthy, you have 36.4 smokers and 63.6 non-smokers. Among the patient with CVD, 88.5 are smokers and 11.5 are non-smokers. So depend upon how you like to talk about it. You may want to talk about it comparing the smokers to the non-smokers, or you want to talk about it as CVD versus non-CVD. You can do it either way. Now, for those that took pharmacoepidemiology, you should remember that it depends on the design. The design of the study will allow you to calculate percentages. If it's a cross-sectional design, you can get all the different percentages you're interested in. So the last thing is, again, cross tabulation, but this time I'm going to request the total percentage, and sure enough, you get 39, 22, 4.5, and 33.8. They all add up to 100. You can request all of them at the same time. So you can request all of them. Click continue. I'm going to go back and request the chi-square just to show you that if you do that, you're going to get only the same chi-square. ما في chi-square for every percentage. Okay? Percentages are just the way you'd like to summarize your data, but you only get one table for chi-square. And you see now that you're getting the 3 percentages per cell. Obviously, this is too much. We prefer to have only one type of percentage to be represented. And as I said previously, I prefer to have the percentages for within the groups. Again, one last thing. This time I'm just going to keep the column percentage. And I will add display cluster bar charts. You do that, and you also get a bar chart showing the results. But it's based on count, it's not based on percentages. Okay, so your assignment is you're going to compare the coffee drinkers to the non-coffee drinkers for CVD. Okay, so you'll do that. You generate a table with the chi-square and the odds ratios as well. I'm going to look at another data set that you also have it on SPI, on Blackboard, and it's called the medication OR stratify. This data set is set up the same as the one that we were looking at. It has three variables and it has a count representing the actual weight. Now, RX, I think this is the whether they're taking the medication or not, and AE, I think it's adverse event. I don't remember what OH is, and I think it's like the health condition. Maybe there's three different types of health condition. So what I would like to do is I would like to compare the proportion of people taking medication, whether or not, based on the different types of health conditions they have. So what I did is I actually um, I gave some labels to these variables, and you can also give them some values, but we don't have to do that. All right, so let's work with this data. So the setup, as I was saying, three variables and the count. So first thing, let's go and make sure that it's weighted by the count. I already have done that previously, so if you haven't, please do. So what you will see is something like this. Click on the weight cases by, take count and put it there. Click OK. And then what we're going to do is we want to look at the relationship between the health condition and the treatment. So analyze descriptive frequency crosstab. um, the health outcome is probably the grouping variable. So I'll put in the columns. The treatment Rx, I will put it in the row. And let's go to cells, request the column percentage. And for statistics, we're going to ask for the chi-square as well. Click continue, and I think we're ready to run the analysis. Okay, so I have three different health conditions, maybe like it's a minor condition, moderate condition, and severe condition. And then I'm looking at the percentage of those that are receiving a treatment. So within the first health condition, 47.6% are receiving treatment, which is 100 over 210. Within the second health condition, 45.8 are receiving treatment, and for the last one, it's 50% receiving treatment. If you look at the chi-square, the chi-square's value is 0.877, degrees of freedom 2, and the p-value is 0.645. Therefore, there's no evidence to suggest that the percentage of receiving treatment among the three different types of health condition is different. The null hypothesis, remember, says that they are equal with regard to the proportion of receiving treatment. We fail to reject the null hypothesis, and therefore our conclusion, there's no evidence to suggest that there's a difference. The difference we observed here is only difference at the level of the sample. It's not substantiated by any evidence that there's such a difference at the population level, and therefore we can talk about the differences here being due to chance only and not statistically significant. As I said previously, you need to also check the percentage of the expected, less than 5, and it's 0%, which is a good thing for us, and therefore we can use the chi-square. You will notice that this chi-square is producing less statistics than the one we've used previously. For instance, the Fisher exact test is not showing up, and this is because you do not get the Fisher exact test automatically if you have more than 2 by 2 table. This is a 2 by 3 table, 2 rows, three columns. And that explains the degrees of freedom being equal to 2. The formula for the degrees of freedom is the number of rows minus 1 multiplied by the number of columns minus 1. So you have 2 rows minus 1 that produces a value of 1, and 3 columns minus 1 that produces a value of 2. You multiply these two together, you get a degrees of freedom of 2. Okay. Your assignment is to look at the relationship between health outcomes and side effects and to see if there is a statistical significance there. So you will produce a table like the one I produced with the treatment, and you will look at the p-value as well. Hala, what I would like to do is I would like to create one table where maybe the expected values are small and to show you like that scenario. So let's create a new Excel, SPSS, and just go to variable view. We will call this the groups. We will call this the outcome, and this is going to be the count. So go back here. The group is, I have two groups, 1 and 2. So you go 1, 1, 2, 2. The outcome is either present or absent, so 1, 0, 1, 0. And then at the end, you're going to put your counts. So I will put values that are not very large, hoping that the expected, I will have expected less than 5. So maybe 4, 8, 2, and 14. Okay, so first things first, let's go to data and request that the data be weighted by count. Okay, the next thing we're going to do is we're going to do a chi-square. So go to Analyze, Descriptive, cross tabs, put the group in the column, the outcome in the rows. We're going to ask for chi-square, and we're going to ask for the column percentage, and yeah, let's run it and see what we get. Okay, so great. Look at the chi-square table and look at the A here. It says two cells, and 50% have expected count less than 5. All right, and this is because, as I said, I made it in such a way that I have very small numbers. So if you look at group 1, 4 out of the 12 have the outcome, and in group 2, 2 out of the 16 have the outcome. The difference between the two is this is a 33.3% and this is a 12.5%. You're trying to test if there is statistical significance between these two percentages. Now, in that situation, you're not supposed to look at the Pearson chi-square because you don't have enough expected to look at the Pearson chi-square. What you do is you look at the Fisher exact test, and for the Fisher's exact test, you're going to look at the two-sided. So the p-value, the appropriate p-value to be reported is 0.354. It's still not statistically significant, but this is the appropriate p-value to report. The other thing is, if you're interested in knowing what were the expected count, you can request for that. So Analyze, cross tab, and inside the cells, request the expected counts. Okay? If you do that, then not only you're getting the count, but you're also getting the expected count. So the expected count for this cell is 9.4, 12.6 for this cell, and here we go. We have 2.6 for this cell and 3.4 for this cells. So as we were told previously, 2 of the cells have expected less than 5. The 2.6 for this cell and the 3.4 for that cell. Okay. I think this concludes everything I want to talk about for the Pearson chi-square. I'll see you in the next session.